Okay, so this is our PVT Lab simulator. And the first step is to make sure that we have loaded the right program. We need to check the composition, okay? So as I said, for operating the composition, we can press F10. And as soon as I press F10, the gas chromatograph will tell me what is the composition inside the visual cell. So that brown color is the Cu2. It says the component is Cu2. The Xi is the mole fraction of the liquid component I, and Yi is the mole fraction of the gas. So as you can see, the Xi is 1. We have only one component, so X1 is 1. So it's 100% liquid. We don't have any gas, so the composition of CO2 in the gas phase is 0. As soon as I got some gas, so in the cell, the Y becomes 1 as well because I have only one component. Okay, so that's good. So I'm in the right track. So the next step is, so the initial condition, I collected the CO2. The next step is to check the temperature. So the temperature of the oven is 75.2 degree Fahrenheit. So the experiment that you are going to do is gonna be at a fixed temperature of 75.2 degree. Now I need to find the pressure. As I said, these blue boxes, they show the pressure gauges. So to connect one of them to the visual cell, I'm going to open valve 8. So as soon as I open valve 8, the blue box at the bottom, which says 14.7 psi, is going to show me the pressure of the cell. So if you remember, I said for operating the valve, you need to use F2. So I'm going to press F2. It says enter the valve number. I put 0.08. So, and enter. So as soon as I open valve number 8, the pressure gauge, the blue box, will be connected to the visual cell and it shows the pressure. So the pressure that I have is 2000 psi. The temperature is 75.2. And the component that I have is CO2. And the CO2 is all in the liquid phase, 100% liquid. And how much CO2 I have? I have 10 cc's of CO2. So that brown color shows, the brown box shows the volume of the CO2, and that's 10 cc. So we are going to collect the initial condition. So you have CO2, and then at 75.2 degree Fahrenheit, 2000 psi, and the amount of the CO2 is 10 cc's. So what we are going to collect here is you can generate a table in the Excel. So what you can have is on the first column you can put the pressure. The second column you can put the volume of the gas, and then the third column would be the volume of the liquid. The fourth column would be the volume of the mercury, and then the total volume. Okay. We are going to collect the volume of the mercury in case something goes wrong. We know how much mercury we have injected or we have removed. That way we can go back to the original step of this calculations. Okay. So we start from the initial condition, as I said. So at initial condition, where the pressure is 2000, the volume of the gas is 0, the volume of the liquid is 10, mercury we have not injected mercury or removed, so volume of mercury is 0, and total volume becomes the volume of the CO2 in gas plus volume of the CO2 in liquid, so it's 10. So now I want to perform my experiment. So as I said, and you can read from the book, is to find the pressure volume diagram, we start from the liquid. Then we need to remove mercury from the cell. We need to expand the liquid such that the first gas bubble comes out. So to expand the liquid, what I'm going to do, I'm going to first open the valve number 9. So I press F2, and then I put 09 and enter. So I open valve number 9. So now I have my hand pump being connected to the visual cell. Now I want to remove some mercury because I want the liquid in the visual cell to get expanded. So we press F5. So if you remember, F5 was activating the hand pump. It says enter injection volume. I don't want to inject, I want to remove. So I'll put minus. I can remove any number, to just, But to just start with, I'm going to remove 1 cc. Let's see how it goes. So I press once, the 1 cc goes to the hand pump. I press twice, the hand pump starts removing mercury. So I have removed 1 cc of the mercury from the cell. It's a good idea to always shake the cell, even though it's not going to change much here, but it becomes a good practice. So I'm going to press F6, and then it says LC pump circulating, and you saw that pump turn to red. So it starts shaking the cell to make sure everything comes to the equilibrium condition. Okay, it's done. So now I collect the pressure. The pressure now raised to 1380, dropped to 1382.4. That's my pressure. The volume of gas is still 0. Remember, the yellow box shows the volume of the gas. That's 0.000, okay? The volume of liquid is now 11, and I have removed 1 cc minus 1 from the mercury. And the total volume of the liquid is 11. Remember, the total volume is the volume of the gas plus volume of the liquid. So that's equal to 11, okay? So this is the first step. So if I look at the pressure volume diagram, now I have the second point. Remember, the bubble point was defined when the first gas bubble comes out of the liquid, okay? So here we are going to define the first gas bubble as the volume of the gas being equal to 0.001 or 0.002, because that volume meter that we have, the yellow box, has the accuracy of 10 to the power minus 3. So the smallest amount of gas that it can detect is 0.001. But since the accuracy is also plus minus 0.001, 0.001 or 0.002 can be considered as the smallest amount of gas that can be detected. So we are going to remove the mercury such that the first gas bubble appears. So I'm gonna remove more mercury. So again, I'm gonna press F5, and then I'm gonna remove 1 more cc. Okay. So I removed 1 more cc. I can shake the cell again. So the pressure dropped to 1084.2. So I record that pressure. The volume of gas is still 0. The volume of the liquid, now I have 12. The amount of mercury removed, I removed 1. So the total volume is 12 now. So I have the information required. So still I'm above the bubble point. Still all the system is in the liquid. So my liquid, my 10 cc liquid, could expand to 12 cc by simply dropping the pressure. Okay. So I'm going to continue this. I press F5 again, and I'm going to remove another cc. Okay. So the pressure is now dropped to, and I'm going to shake this out. The pressure dropped to 940.86. Still no gas presented, and my volume of the liquid increased to 13. Okay, and the total volume is 13. So my liquid could be able to expand by 3 cc's. Okay, so 30% increase in the volume. Still, I don't have any gas. So I keep going. So I'm going to remove 1 more cc. Okay. So now as soon as I remove this, now the amount of gas is 1.073. So it means I have passed the bubble point. Okay. So I have to go back. Okay, I'm not going to collect this point because I passed the bubble point. I just collect the points till I get to the bubble point, and then after that, if I pass the bubble point, I need to go back to the previous step. Okay, so this is and I already have 4 points above the bubble point, so I can draw the best straight line through those 4 points. So at this point, the only thing that I need to do is to find the exact bubble point. So I'm not going to collect this information because I passed the bubble point, and that 1 cc was too much. So here it says the amount of gas I have is 1.073. So instead of putting all those 1 cc of mercury back, I'm gonna just inject. I'm gonna put F5, activate my hand pump, and I'm going to inject 0.5 cc of that mercury back into the cell. So I removed 1 cc, it was too much. I passed the bubble point. So I put the 0.5 cc back. So still I'm above the bubble point because the volume of gas is now 0.287. So I'm gonna put back, so I'm not collecting any data points now. I'm just trying to find the bubble point. So I put F5 again. That activates my hand pump. And this time I'm gonna put 0.2 cc's back. So remember, I removed 1 cc, it was too much. So I put 5.5 cc and then I put 0.2. So now I'm above the bubble point again. So 0.2 was too much. So I'm going to this time remove 0.1 cc from the cell. So I removed this time 0.1 cc, and again I passed the bubble point. So 0.1 cc is too much, so I'm gonna inject back 0.08. Okay, so the amount of gas is 0.003. I'm very close. Remember, if I said if the volume of gas becomes 0.001 or 0.002, that's my bubble point. So I'm very close. So I'm gonna just inject 0.002 back into the cell. So that was too much. So I'm gonna remove minus 0.001. Okay, and I'm gonna shake the cell. So now what I did, I get to the point that I have only 0.002 cc's of gas. So I can consider this as a first gas bubble. So now I'm gonna collect the information. So at this point, the bubble point is 914.1 psi. The volume of gas is 0.002. The volume of liquid is 13.317. The volume of mercury, I removed 3 cc's before, so the volume is now 3.319. So it's minus 0.0319. And the total volume is, I have 13.317 of the liquid and 0.002 of gas, so it becomes 13.319. Okay, so I have collected the information that's required to get to the bubble point. Now I just need to have 1 or 2 points in the two-phase envelope and 1 or 2 points in the gas phase. So to get those points, I'm gonna activate the hand pump and remove more mercury. This time I'm gonna remove, let's say, 10 cc's. Okay. So I removed 10 cc's, I'm gonna shake it. So as you can see, the pressure stayed constant. So the pressure is still 914.1, so I collect that. The volume of gas raised to 15.729. The volume of the liquid dropped to 7.59, and I removed 10 cc's. Okay, and the total volume is the summation of 15.729 plus 7.59, the volume of the gas plus liquid. So I'm still in the two phase, so I'm going to remove more. I'm going to remove minus 10 again. Okay, so now if I collect this information, again, the pressure is still 914.1. The amount of gas is 31.456. The liquid is 1.863, and I remove another 10 cc's of mercury. And the total volume is simply the summation of liquid plus gas, 1.863 plus 31.456. So we will continue this in the next part of the lab till we get to the dew point and collect more points below the dew point.